Okay, this is a video over geometry, Unit 1, Section 4, which is proofs. And I want to go through some more of these proofs and talk about how I do them, how to understand them, because when you go through them, if you're just doing them on your own and me just telling you how to do them, it's a little bit difficult. So here's what I want to do. Here's our proof. And remember how we write all this stuff down. Okay, we do a T-chart, and we write our statements and our reasons, okay? And the first statements that we want to do is we want to write down our given statements, okay? So number one, I'm going to write down that angle ABC, and let me...
What is that word up there?
Which one? This one? Statements, and then reasons. So if you wouldn't mind turning your music off for just right now, just to listen to me, go through this with me, please. Okay, grab a pencil. So my statements, my first statement that I want to write are my given statements. Okay, so angle ABC is congruent to angle DEF. Okay, the reason why I put that down as a statement is because it was given to us. It's like Christmas. Okay? Okay, and the second statement that we have, number two, is the second given statement. So angle GHI is congruent to angle DEF. All right? And again, that's also given to you. Okay? Now, you are asked to prove that angle ABC is congruent to, or the measure of ABC is equal to the measure of angle GHI. All right, there's just a lot of stuff going on, right? And you're like, okay, how do I prove that? What do I need to do? All right, and it's confusing because there's really, to you, it's very abstract and it's not concrete, all right? So here's what I do. I'm going to draw a picture of this situation. I'm going to draw a picture of angle ABC. Okay, so I'm going to come over here, and I'm just going to draw a generic picture of angle, and I'm going to call a point here A. B needs to go in the middle at the vertex, point B, and then point C. Okay? And how big do you want to make this angle? Alan, how many degrees should that angle be? It's an acute angle, so it needs to be less than 90. Okay, we'll call it 60 degrees. Perfect. Okay, 60 degrees. All right. So then, here's what we know. Angle ABC is 60 degrees, and it's congruent to angle DEF. Okay, so let's also draw a congruent angle, and make it look the exact same. Okay, I'm going to put a point here, put a point here, and put a point here, and call that DEF. Now, if they're congruent, what's the measure of this angle? 60 degrees. Okay? Okay. Reasonable? We all good? We all agree with that? Those are two the same, they have the same measure? Okay, now the next statement says that angle GHI is congruent to DEF. Well, here's DEF. What's DEF? 60 degrees. So if I draw another angle, and I call it angle GHI, and I know that this angle is congruent to this angle, then I'm going to call this one 60 degrees as well. Okay? So, what can you conclude about angle ABC and angle GHI? They're equal. Their measures are the same, so they are what to each other? Congruent. So let's make that as our third statement. Our third statement is that angle ABC is congruent to angle GHI. Now, does anybody know the property that we use for this? Look on the page before. Begins with a T. Ends with transitive. It's the transitive property. So 3 is the transitive property. Is it transitive or transitive?
Transitive.
Transitive. Okay, transitive property. Okay, I would be okay with this. I'm call it good that you're done. Okay, but there is another step in here to get this actual last statement. The fourth statement is that we say the measures of ABC is equal to the measure of angle GHI. And the reason why we can say that, that's the definition of congruent angles. Okay, congruent angles. Okay, edgenuity will require that fourth step.
What's the second first one?
Which one? This one?
Yeah.
Oh, definition. Definition of congruent angles. There are a lot of abbreviations in geometry. Okay? But, and guys, here's the thing. You might not be terribly accurate with this stuff, but I want you to be able to see the logic here. Okay? Kind of hard. It is hard. Okay? But the objective is write down your given statements and then write a story that gets you to your ending statement, proof statement. Right. Yeah, logically you can think it through. Logically, this stuff should make sense.
I don't get the reasons part either.
The reasons is kind of hard. There are certain things that we could say. It's like, okay, if this is equal to this and this is equal to this, then these two first and last things have to be equal. And that's just a property that we have. That's just one of the things that we use in geometry to tell us that. It's hard. This isn't easy. That's why I'm going over it. All right? But here's the thing. We have to stay positive. Everything's going to be okay. All right? I like proofs. I think they're fun. You guys probably think I'm nuts. Uh-huh.
So it's like,
Yeah.
okay, I get
Yeah.
this stuff.
Yeah, and that's okay. But, and it's hard going from like just these like symbols and words to this. My trick is I have to actually draw out a picture, and I think that'll help. And we'll have a chance to also, we don't have to always do the statements. Like I'm okay with you just having a logical flow I'm okay if you guys can only get the statements. The reasons are what they are. Okay? I'm hopeful that you guys can actually logically go, okay, well, yeah, this works because this works, and then we know that these things are true.
It's just that, it's like, oh, how do I know if it's transmitted?
Right. Yeah.
Do we always want to draw a picture?
I do. Because I like pictures. Yeah. Okay, so let's go through this next one. Okay? All right, so you're given that AB is congruent to CD, and so this is the same type of problem. Okay? Segment AB is congruent to segment CD. Well, let's draw that.
Okay, I have a question.
Uh-huh.
Okay, why is any of this even a thing if it already has the answer right there?
We want to understand the logic.
Apparently congruent to CD and EF is apparently congruent to, if they want to prove it, the other one. I don't.
It's all about the logic.
So we're just.
To go from one step to the next. That's it. It's logic. It's like doing those logic puzzles. It's like doing Sudoku. Well, but the thing of it is like, it's about you justifying your reasons. You have and your questions are valid and they're reasonable. But here's the thing. You do something wrong, your parents or somebody of authority says, "Why did you do that?" You know what I mean? Like if you do something, it's for a reason.
But I'm wondering if it's already given to us, why do we have to
Sometimes the proofs are 8 or 9 steps long.
It's not to prove it because it shows that we have math.
Shows that you understand the logic of how it works. Yeah. It's hard. I know. Got to persevere. We gotta persevere
I
and.
don't think it's hard, it's just like, it's not like any like math, it's just like, it's just like a technique.
Every time you solve an equation, you're really doing a proof, though. It's a process. It's all about the process. Following patterns, drawing conclusions. All right, so let's draw a picture. AB is congruent to CD. All right, so I'm going to draw that. I'm going to say AB. And let's say that AB is 7 inches. Okay? Yeah. Now, let's draw another segment, CD. So if AB is congruent to CD and AB is 7 inches, what does CD have to be? 7 inches. Okay? All right. Now, the other given statement is that EF is congruent to CD. So let's write that. Okay, let's write out EF. And if CD is 7 inches, then what's EF going to be? 7 inches. Okay, makes sense? So all three of them are congruent? If these two are congruent and these two are congruent, then these two have to be congruent, right? So let's write this out. Let's draw out our T-chart. Practically, yes. Just with segments and not statements. Reasons. First statement was AB was congruent to CD. Happy birthday. Birthday came early. It's given to you. It's a gift. Number 2 is that EF is congruent to CD as well. Again, someone's thinking about you. Someone gave you a gift. And what do you say, Alan, when someone gives you a gift?
Thank you.
You're welcome. So now, okay, AB is congruent to CD, EF is congruent to CD. Then the third statement we would say is that AB is congruent to EF. The reason why is the transitive property.
I have a question.
Uh-huh.
Why isn't it just not given, even though it's given?
It's not given.
Then I wouldn't know what.
Then you have to come up with something that, like, leads you to the next step, to draw you to the next conclusion. And we have that property. It's a transitive property.
So even though it's given to you, you don't write given, you write like.
Well, but this isn't given to us. We have to conclude that.
Look at the paper and I already knew it.
Well, right, I know.
I knew it because it was given.
But it's all about the process.
But even though, what I'm saying is like, even though it is given, you write down what the process was.
Well, but this step wasn't given to us. AB is congruent to EF. It is not under the given category. This is what we need to conclude. Okay? Valid questions. Valid questions. And that's it. We're done.
Wait, what about the fourth?
Oh, fine. So the fourth statement, you could say that measure of AB is equal to the measure of EF, and that's the definition of congruent segments. If you're getting to this point, if you get down to the third step, you're like, yeah, I know that because it's the transitive property.
So, like, the
Boom.
first step will always be transitive?
Not always. This is just the introduction to proofs. Yeah, well,
Because I've seen it before where it's like that's kind of sometimes a lot. But it's like,
yeah. Okay, now this is a flow chart proof. Uh-huh. Okay. Flow chart proof. Okay. So usually what you want to do is for under each box you want to provide a reason. Okay, AB is congruent to CD, EF is congruent to CD. Okay, that's under the given category. This is the gift. First box is the gift. It's given. Okay. And then what they do is they take, to go from this step to this step, instead of saying EF is congruent to CD, they say CD is congruent to EF. Anybody know what property that is?
The flipping one?
So the flipped one. So go turn to the back page, and you have those list, the page before, and you have the list of properties. Which one do you flip across the congruent sign?
The symmetric.
Symmetric property. So this one would be, and I wouldn't require you to do that. Symmetric property. Okay, and then we know that, so to go from AB is congruent to CD, CD is congruent to EF, then you would say that AB is congruent to EF, okay, which is essentially what we're trying to prove. That's the transitive property. Okay, and then you say that their segments are equal, and that's a definition of congruent segments. Okay, so we did the same proof, just two different ways, writing it two different ways. A lot of times, what you can end up doing is just writing it out in paragraph form, and just saying, well, this is equal to this, so this, you know. Instead of you actually putting it in a T-chart or a flow chart, you can just write it out and write out your logic. Having fun yet? Sorry, Andrea. Okay. Ooh, which information do you know is true about this diagram?
The first four, not the last one.
Well, ABD is a right angle. So, okay. So I see this. I see that I have a right angle here. ABD is a right angle. That is true.
And ABD also equals 90 degrees.
And therefore, it would equal 90 degrees. That is true. Okay. Now, do you know, does BC, does this ray right here, does it bisect this angle? Does it cut it in half?
Yeah, but not really, because it doesn't say so.
It doesn't say so. It sure looks like it, right? But we have no indication that these two angles are congruent. So if we've got no proof, we can't draw that conclusion. All right? It's all about drawing conclusions. It's like, yeah, so we don't know if it bisects, that's false. So we don't know if it's 45 degrees or if that's 45 degrees. You know, I've drawn a conclusion about Mr. Smith. You ever notice how when you go up and talk to him, he like stares at his computer and he like acts like he doesn't listen to you?
Yeah.
And he doesn't pay enough attention to you? I've drawn the conclusion that he doesn't like to pay attention to me. Okay, I have needs. All right? I need to be felt supportive by my superior, as like Mr. Smith. You know, I want to feel like I mean something to him. But every time that I go and talk to him, and he's just sitting there staring at his computer.
You just said yeah.
Yeah.
Dealing with adults, he likes kids better.
Yeah, I know. So I've drawn the conclusion that Mr. Smith does not pay enough attention to me.
You should let him know.
Oh, I have. But you know, I'm noticing, and that's the thing. It's like I'm drawing a conclusion. I'm seeing what's happening, and I'm drawing a conclusion. Whether I'm right on that conclusion, that one has yet to be seen. Ooh. Check out this last one. This last one looks pretty good. Okay. Given, ooh, yeah. All right, here's what we got. Given that C is the midpoint of AB, prove that the length of AC is 5 centimeters. Okay, what does the midpoint do?
Bisects right in the half.
Yeah, bisects right in the half. So midpoint, I like to use the word cuts in half. Cuts in half. Another word for that, you're right, is bisected. Okay? So if C is a midpoint, then it cuts it in half, then what am I left with? What do we know about AC and CB? Well, they have to be 5, and we already kind of know that. But what do we know about those two? AC is then what to CB? Half of it. But it cuts it into two, cuts in half. Let's also write this. It cuts into two congruent parts. Okay? So and that's a thing, is like, if you're given that information, hey, C is a midpoint, all right, then what I do, if C is a midpoint, then I come in here and I draw, oh, well, I know AC and AC and CB are going to be congruent, okay? So you're given these two statements. You're just given the two given statements. C is the midpoint of AB, and that AB has a length of 10, and that was from the picture. It was given to you from the picture, all right? So now, but let's think about, just from this information, C is the midpoint of AB. We then conclude that AC is congruent to CB. You guys automatically think that. You know what's happening. We just have to actually write it down, okay, and put that as our third step. Okay, so let's write that. Let's say in our third step that AB is congruent to CB. No, wait a minute. AC is congruent to CB. Sorry. My bad. Okay. And the reason why we know that is because we were given the fact that C is a midpoint. So that what we're going to do is we're going to call that the definition of the midpoint. Okay. All right there, buddy? All right. Yeah, this whole thing's been recorded too. We got like 22 minutes. Okay. All right, so then the other thing that I know, C is the midpoint of AB. All right, so how do we logically then say, we know AB is 10. Oh, let's do this. Well, we know it's 5. We have to think about the logic. Okay, the next one. Okay, we could say in step 4 that if I take AC plus CB, if I take the two small segments, AC plus CB, what am I going to get as a result? Well, AB. Okay? You guys know what that is? Remember what that is? Add two small segments together to get the big segment. What do we call that? But what are we adding?
The addition of segments.
Segment addition postulate. Okay, so let's write that down. So that's the segment addition, segment add postulate. Okay. Okay, now I know what to do. Now I'm going to do this. Okay. On step 5, and we're trying to, AC is 5 centimeters. Okay. So what I want to do is I'm going to say this. I'm going to say that AC, okay, segment AC plus segment AC is equal to 10. Now let's think about that. How come I replaced CB with AC? Because they're congruent. I substituted that in. Well, you'll see why. Because I have to arrive at a conclusion that AC is equal to 5. logically through mathematics,
It's like saying 5 is 5.
basically. Okay? Then the other thing is I replaced AB with 10. Okay, again, I took that fact and I substituted it down here. Took this fact, substituted it down here. So the reason why I wrote that was because of substitution. Okay? I replaced things. Okay, step 5, step 6, I would do this. I would take AC plus AC. That gives me 2 times AC. Oh, yeah. Is equal to 10. Because we got to arrive that AC is equal to 5. We have to logically show how to get from one step to the next. I know. But you understand what's going on.
Just like agreed with me.
I know, I agree with you. I guess. All right. Now what I did there is I just combined like terms. Combine like terms.
You just wrote the same thing again.
No, I didn't.
2 AC instead of putting AC and
Well, yeah, but you know what? But think about what I'm doing. I'm starting out with this statement here, segment addition postulate, and I'm just trying to logically prove step by step that AC will equal 5. Now what I would do, I would divide it by 2, divide it by 2. So then in step 7, AC is equal to 5. And I call that, if you divide by something on 2 sides, that's the division property of equality.
would you fail us if we didn't put all that extra stuff?
I will not fail you because we will learn it.
Learning.
What if we choose not to?
normal knowledge.
Proofs are a part of the curriculum. And I value, I know how frustrating this is. I truly do. In college, once you get beyond like Calc 3 and differential equations, then you start taking classes that involve just proofs. Yeah. So I had like 3 years of this.
Yeah, but you enjoy math. Why else would you be a teacher of math?
It's easy to find a job. I tricked Mr. Smith into hiring me. You know,
I'm just like,
he thinks I know what I'm doing.